Here's a photo of what the world looks like today. Now, scientists have told us that this is not how the Earth has always looked. How do they know such things? Well, first we will look at 4 different fossils that have been found around the world. The first fossil we will look at is that belonged to Cinnonathus. This was a predator and is believed to be related to mammals. The Cinnonathus will be represented with yellow squares on the map. The Cinnonathus has been found along the west coast of South America and in Central Africa. The next fossil we look at is that belonged to Mesosaurus. This reptile is thought to have spent a majority of its life in the water. The Mesosaurus will be represented in an orange square marked on the map. The Mesosaurus' fossils were found in the southern part of South America and the southern part of Africa. The Lystrosaurus was an herbivore, approximately the size of a pig. On the map, the Lystrosaurus will be represented in black. The Lystrosaurus was found in the southern part of Africa, India, and even in Antarctica. Lastly, we have the Glossopteris, which was a fern, yet was as big as any trees we have today. The Glossopteris will be represented in green squares on the map. The Glossopteris fossils have been found in southern part of South America, southern Africa, Madagascar, India, Antarctica, and even Australia. So, how is it possible that all of these fossils have been found scattered across the Earth with giant oceans separating them? Well, to find the answer, we might want to go back to approximately 100 million years ago to 300 million years ago. For about 200 million years, all of the land mass on the planet was one large supercontinent called Pangaea. And during this time, it was easy for animals to travel all around the world without having to swim. Now it is easy to see how the fossils are dispersed around the world. The animals had access to almost every corner of the continent. Fossils can tell many stories. Sometimes they give us more questions than answers. Like when marine fossils are found on top of large mountain ranges, like the Appalachian Mountains or the Himalayas. Let's travel back to approximately 458 million years ago to the Ordovician period. This is what the Earth looked like at that time. And let's say that this line represents the equator. That meant that most of the landmass was below the equator. This little section right here is present-day Siberia. This continent is called Laurentia and is made up of present-day North America, most of which is underwater. This is North America's eastern coastline. This is part of Europe. As you can see, most of it is underwater. The rather large landmass over here is a supercontinent called Gondwana that at this time is going through the breaking up process. The arrow is specifically pointing to India, but there is also Australia, Antarctica, Africa, and South America. In between North America and its eastern coast, and also part of Europe, was called the Iapetus Ocean. The marine fossils found on the Appalachian mountaintops actually came from the Iapetus Ocean. Slowly, the Iapetus Ocean started to close up when the eastern coastline of North America and part of Europe started drifting towards North America. The Appalachian Mountains were created when the 2 or 3 collided. This also gives scientists the theory that the Appalachian Mountains continue into Europe. When 2 continents collide, they form what is called a convergent boundary. Using food, I will show you what a convergent boundary means. In this example, fluff will represent our mantle. The cracker represents the continental crust. The frosting will represent the soil and other things that are on top of the crust. And then the space in between the crackers and the frosting will represent the Iapetus Ocean. You will see, as the 2 crackers collide, one is forced under the other. But there is quite a lot of material built up, which represents building a mountain range. This is how many mountain ranges are formed, including the Appalachian Mountains and the Himalayas. Now, if we go forward in time to approximately 100 million years ago, Pangaea, the supercontinent, started to break up. If you watch, you can see how India travels all the way up above the equator to smash into Asia. This, just like the Appalachian Mountains, is how the Himalayas were formed, and are still forming. They grow about 1 inch per year.